We probably ought to look at some algebra while we're here. That's always a good thing. I don't remember if we have any videos, so I'm going to share it like this. If I need to change it, I haven't looked at this since Friday, so I don't remember if I had videos. I'm sure there's a video. I'll end up changing it the other way, but let's get started. All right, let's look at the grade screen as usual. All right, Module 5, that's a couple of weeks in the past now, so hopefully you've got everything turned in from that. We've had 2 weeks, week 24 and week 25 of matrices. So you should have all that turned in. Last week, under week 25, we had one assignment, the matrix row operations, and we had the quiz 1, and it was over the past 2 weeks. So hopefully you've got everything finished through there. If you didn't do well, go back and redo it. It's not that hard. Those are 4 problem things on Khan Academy. You can redo those if it didn't go well, because a lot of people are really raising their grade this unit because the matrices are not that bad. But this week, what do we have? Week 26, we have 4 things to turn in. This is kind of a heavy week, but the next week, we're just going to have the quiz. Is that all I got next week? Yeah. We'll look and see how much this is. I may move some of it to be with next week's quiz. But we're going to start looking at the adding and subtracting matrices before we make that decision. All right. So we can close week 25. And we'll open week 26 because that's where we're at now, week 26. Okay, adding and subtracting matrices. That's the first part of it here. So, there is a video, adding and subtracting matrices video, followed by a lesson, and then the 2 assignments.
Let's think about how we can define matrix addition. And mathematicians could have chosen any of an arbitrary number of ways to define addition, but they've picked a way to define addition that seems, one, to make sense, and it also has nice properties that allow us to do interesting things with matrices later on. So if you were one of these mathematicians who are first defining how matrices should be added, how would you define adding this first matrix over here to the second one? Well, the most common sense thing that might have jumped out at you, especially because these 2 matrices have the same dimensions. This is a 2 by 3 matrix, has 2 rows and 3 columns. This is also a 2 by 3 matrix, 2 rows and 3 columns, is to just add the corresponding entries. And if that was your intuition, then you had the same intuition as the mathematical mainstream, that the addition of matrices should literally just be adding the corresponding entries. So in this situation, we add 1 plus 5 to get the corresponding entry in the sum, which is 6. You can add -7 plus 0 to get -7. You can add 5 plus 3 to get 8. You can add, and I'm running out of colors here, you could add 0 plus 11 to get 11. You can add 3 to -1 to get 2. And you could add -10 plus 7 to get -3. And if you see this definition of matrix addition, you see that it actually does not matter in what order that we actually add these matrices. I could have done this the other way around. If I did this the other way around, let me copy and paste this. So if I were to add this matrix, so let me copy and let me paste it. If I were to add it this way, that matrix to, let me copy and paste the other one, to this matrix. So copy and paste. If I were to go this way, you'll see that the order in which I'm adding the matrices does not matter. So this is just like adding numbers. A plus B is the same thing as B plus A. What we'll see is that this won't be true for every matrix operation that we study. In particular, this will not be true for matrix multiplication. But if you add these 2 things, using the definition we just came up with, adding corresponding terms, you'll get the exact same result. Up here we added 1 plus 5 and we got 6. Here we'll add 5 plus 1 and we'll get 6. We get the same result because 1 plus 5 is the same thing as 5 plus 1. Here we had 0 plus -7. You get -7. So you're going to get the exact same thing as we got up here. So when you're adding matrices, if you were to call this matrix right over here matrix A, which we normally denote with a capital bolded letter, and you call this matrix right over here matrix B, then we take the sum of A plus B, which is this thing right over here, and we see it's the exact same thing as matrix B plus matrix A. Now let me ask you an interesting question. What if I wanted to subtract matrices? So let's once again think about matrices that have the same dimensions. So let's say I'm going to have two 2 by 2 matrices. So let's say it's 0, 1, 3, 2. And from that, I want to subtract -1, -1, 3, 0, and 5. So you might say, well, maybe we just subtract corresponding entries. And that indeed is how you can define matrix subtraction. In fact, you don't even have to define matrix subtraction. You can let this fall out of what we did with scalar multiplication and matrix addition. We could view this as the exact same thing as taking 0, 1, 3, 2, and to that we add -1, -1 times -1, 3, 0, 5. And if you work out the math, you're going to get the exact same result as just subtracting the corresponding terms. So this is going to be, what is this going to be? 0 minus -1 is +1. 1 minus 3 is -2. 3 minus 0 is 3. 2 minus 5 is -3. And you'll see that you get the exact same thing over here. When you multiply -1 times a -1, you get a +1. +1 plus 0 is 1. -1 times 3 is -3. Plus 1 is -2. Fair enough. There might be a question that is lingering in your brain now. Okay, Sal, I understand. When I'm adding or subtracting matrices with the same dimensions, I just add or subtract the corresponding terms. But what happens when I have matrices with different dimensions? So, for example, what about the scenario where I want to add the matrix 1, 0, 3, 5, 0, 1 to the matrix, so this is a 3 by 2 matrix, and I want to add it to, let's say, a 2 by 2 matrix, 5, 7, -1, 0. What would we define this as? Well, it turns out that the mathematical mainstream does not define this. This is undefined. This is undefined. So we do not define matrix addition or matrix subtraction when the matrices have different dimensions. There didn't seem to be any reasonable way to do this that would actually be useful and logically consistent in some nice way.
All right, there you have it. Addition and subtraction can only be done when the matrices are the same size. 1 by 3, 2 by 3, 4 by 1s, whatever size they are, both of them have to be the same size. So if they're the same size, it's not a problem adding and subtracting. If they're not the same size, you can't do it. It's undefined. You cannot add and subtract unless they are the same size. So let's go back and look at the next lesson. This will be a similar thing, except it'll just be the lesson part, not the video. All right, to make it bigger, we can close this little screen on the side. All right, what you should be familiar with before taking this lesson. A matrix, we already know this is a 2-row by 3-column matrix. So it's 2 by 3, because we learned that a couple weeks ago. So what we'll learn here is as long as the dimensions of the two matrices are the same, we can add and subtract them. So adding matrices, if A is 4, 8, 3, 7, and B is 1, 0, 5, 2, let's add A plus B. So all we have to do is take the first term on the first row, first column, add it to the first row, first column term on the other matrix. 4 and 1. So add those together, it's 5. 8 plus 0. 8. 3 plus 5. Right there, it's 8. 7 plus 2 is 9. All right, just like he explained in the video. Another example for you, something you can go back and refer to if you're not sure. So let's add this one real quick. Let me open up the chat window so I can see what you're putting in there. If this is our A matrix right here, and this is our B matrix, what is A plus B added together? What's the first row? What's the second row? What's the third row? I think you guys can nail this. 7 and 5. I see 7 and 5 there. Perfect. All right, next. Yep, we got a 0 and a 4. So add those together. We got 1 plus 1, 2. All right. See several of you got that. Great. All right, now add the third row. It's like being back in first grade, isn't it? What's 1 plus 0, everybody? Our childhood. 111. You're right. Let's check it. Green check mark. Good job. All right. Let's do. We'll skip this one because I think you guys can add 2 single-digit numbers together. You know, for like the last 10 or 11 years, you can probably do it. Let's subtract. Okay, subtracting get a little tricky when we deal with the negatives, right? All right, so it says subtracting it works the same way. We take the first row, first column of each matrix, 2 minus 5. In that case, you get a negative number. 8 minus 6, you get 2. 0 minus 11, 9 minus 3. All right, so here's the problem. Let's see. Let's do the big one. Let's do the second one here. Problem 4. What is the first row if we're subtracting those 2 matrices? This matrix says 3, 4, 9. This one says 1, 6, 7. So we got to subtract the proper term from the proper term. First row. 3 minus 1. Oh, come on. You don't have this already, folks. First row. 3 minus 1. I'm going to slowly go here. 2. 4 minus 6. Negative 2. And 9 minus 7. Oh, not a 3. 2. 2, negative 2, 2. All right, good job. I see a lot of 2, negative 2, 2s. 9 minus 7. All right. Second row. We've got 6, 8, 6 and 6, 4, 2 as the 2 rows, and we're subtracting the second matrix from the first matrix. So 6 minus 6. Up, I'm seeing 0, 4, and 4. 8 minus 4, 6 minus 2. Yep, that all looks good. Finally, we have 7, 3, 4 in matrix A. We have 4, 1, 5 in matrix B. So subtracting the 7 minus the 4. Oh, Madison got it for us. She says 3, 2, and negative 1 because we have a 4 minus 5. All right, let's check our work. Fabulous. All right. Oh, now we're going to talk a little bit about scalar multiplication because that's coming up in our next lesson. It's coming up. Scalar multiplication as repeated addition. So this goes back to the basic principles of mathematics. If we have this matrix A and we want to find A plus A plus A, we're just adding it to itself. We're going to take 3 of those and add them together. That would be the same thing as multiplying times 3, right? Same as 3 times the matrix, right? We learned that if we take 4 plus 4 plus 4, that's the same as 3 times 4. So this shows both ways of doing it here. A plus A plus A, we write the same matrix 3 times. We add the elements together, 4 plus 4 plus 4, then 8 plus 8 plus 8, and 2 plus 2 plus 2, plus 1 plus 1 plus 1, to give us our 4 elements of the new matrix. Or we take 3 times 4, 3 times 8, 3 times 2, 3 times 1, and that'll get the new matrix, which is 3 times 4, 8, 2, and 1. Now, they didn't actually give us the final answer. They just converted it from that to that. But we know it's 12, 24, 6, and 3. But it equals A plus A plus A equals the same as 3A. That makes sense. 4 plus 4 plus 4 would be the same as 3 times 4. All right. Subtraction as the addition of the opposite. Oh, yeah. So we're talking about, as he showed in the video, if you have A minus B, that could be the same thing as A plus negative B. Everything in B would be taken times negative 1. Negative 1 times B. And that's the end of that lesson. Let's look at the assignments. We'll look at the first one together here. Let's close that little side tab. Okay, so add and subtract matrices. Find the sum. 310 negative 2 is being added to 403 negative 1. Now I want to look at these real quick. I'm gonna put 7, 1, 3, and negative 3. Check. Hey, got that right. Just want to see if it does any that's not possible. Oh, here's one with the X and the Y, like we had in the quiz. If 2, 3, negative 1x is added to y, negative 5, 4, and negative 2, what does x and y have to be for ended up 0, negative 2, 3, 2? All right. Not that difficult. The only thing to remember about addition and subtraction, the big thing, you don't have the assignment in your Khan Academy. All right, Addison, I'll go back and look at the settings in Khan Academy because it should have it in it. I don't know. Are you signed into Khan Academy? Make sure you're signed in. It should have your name up at the corner. Okay. I'll double check it. Thanks for letting me know. So the only thing to remember about addition and subtraction is they have to be the same size matrices. If they're not, it's undefined. There's no answer. We cannot add them unless they're the same size. Same number of rows, same number of columns. That's the big thing. It has to be. All right, let's look and see what the other assignment says. Addition and subtraction assignment again. See how this one's different. Okay. This one says if we have matrix X, and it doesn't give you matrix X, but we subtract this matrix from matrix X, and this is the answer, what did matrix X have to be to end up with this answer? If we're subtracting negative 20 and we end up with the number 13, what was in that first row, first column? Well, that had to be a negative 7, right? Negative 7 minus negative 20, which means we add 20 to it, would give us a positive 13. So that's the type of things you're doing in the second addition and subtraction. All right, let's go back here. Okay, that was the first folder on week 26. Here's the second folder. So we're going to look at multiplying matrices by scalars, which we've kind of looked at just in this last lesson. This is a video, so that means I'll have to open it up and go back and share the other way again. All right, let me switch this.
Now that we know what a matrix is, let's see if we can start to define some operations on matrices. So let's say I have the 2 by 3 matrix, so 2 rows and 3 columns, and the entries are 7, 5, negative 10, 3, 8, and 0. And I want to define what happens when I multiply 3 times this whole thing. So first of all, let's get a little terminology out of the way. The number 3 in just the everyday world, if you weren't dealing with matrices or vectors, and if you don't know what vectors are, don't worry about them just now, you would just call that a number, or you would call this a real number. It's just a regular number sitting out there. But now in the world where we have these new structured things, these matrices, these arrays of numbers, we will refer to these just plain old real numbers that aren't part of some type of an array here. We call these scalars. We call this a scalar. So essentially what we're defining here, we don't know, I haven't said what this is actually going to turn out to be, but whatever this turns out to be will be a product of scalar multiplication, or we're multiplying a scalar times a matrix. And so how would you define this? What do you think this should be? 3 times this stuff right over here. Well, the world could have defined scalar multiplication however it saw fit, but one way that we find perhaps most obvious and most useful is to multiply this scalar quantity times each of the entries. So this is going to be equal to 3 times 7 in the top left, 3 times 5, 3 times negative 10, 3 times 3, 3 times 8, and 3 times 0, which will give us, it didn't change the dimensions of the matrix, it didn't change, I guess you could say, the structure of the matrix, it just multiplied each of the entries times 3. So the top left entry is now going to be 21. The middle entry, or the entry in the middle row top column is going to be 15, negative 30, 9, 24, and 0. So when you multiply a matrix times a scalar, you just multiply each of those entries times that scalar quantity.
All right, called a scalar because we're scaling it by that amount. We're scaling this to be times 3, right? So that's kind of why they call that a scalar. So let's go back and see the written lesson that goes with this. So if we go to the next one, multiplying matrices by scalars lesson that goes with it. Close this little side tab. All right, again, what you should be familiar with is just make sure you know what a matrix is. It reviews that every time. It says you should also know how to add and subtract matrices, which is what we looked at earlier in class. So we're going to learn about scalar multiplication, which the video just explained to us. So given that A equals 10, 6, 4, 3, let's find 2A. 2A. So all we have to do is multiply everything inside the A matrix times 2. 2 times 10, 2 times 6, 2 times 4, 2 times 3. So the 10, 6, 4, 3 becomes 20, 12, 8, 6. All right. Now they want us to do, and right off the bat, they're going to make it a little trickier than 2B. They're going to do negative 3B. So if this is B, what is negative 3B? Well, negative 3 times negative 4, positive 12. Negative 3 times negative 2, positive 6. Negative 3 times 7, negative 21. Negative 3 times 1, negative 3. Let's check. Check mark. We got it. All right. Oh, I want to give you the hard one. There you go. Let's see who can give me these 3 numbers. If C is the matrix that's negative 42, 27, and negative 3, find 1/3 C. So you're just multiplying those numbers by 1/3, which really, if you multiply by 1/3, that is equivalent to dividing by 3. That's the same thing as dividing by 3, multiplying by 1/3. Oh, Isaac's got it. Anyone agree with Isaac? So negative 42, all right, Lee agrees. Negative 42 times 1/3 is negative 14, absolutely. 27 times 1/3, or divided by 3, is 9. And negative 3 times 1/3, so our negative 3 divided by 3, either way, negative 1. Check. Perfect. Perfect. And that's all the problems they give on that one. All right, let's close that out. Let's look at the assignments that go with this. Multiplying matrices by scalars. Close that little side tab again. Ready to practice. Let's go. Oh, find the values of x and y in this scalar multiplication. So this is being multiplied by 3. See the 3 out front. X is up here on the top row. Y is the first entry on the second row. So if we multiply 3 times x and we end up with negative 9, all you have to do is take negative 9 and divide it by 3 to see what you multiplied by. X must be negative 3. Because 3 times negative 3 would be negative 9. How about the y? It equals 6. When you multiply 3 times y, you get 6. Y equals 2. Oh, if you need a calculator for that, they have it right there. Check. Nice work. All right, here's when you multiply this by a half. Enter those 4 in there. So, all right, you should have random problems there. So yours may be different. Let's look at the second multiplying assignment for scalar multiplication. Close the little side window. This is a little trickier because look what happened. We're taking x and multiplying it by 1/3 and then subtracting another matrix from it. So this is the answer after you subtract this matrix from a matrix multiplied by 1/3. All right, maybe we'll do this one together just to get this first out of the way. All right, if we start with 16 as the matrix being subtracted, if we subtract 16 and get -4, what number would that be? If we subtract 16 and get -4, what number did we start with that we subtracted the 16 from? That's got to be, well, it starts out, this is not going to be the answer we leave here. I'm just putting it here so we know it. It might be easier doing paper. 12 minus 16 would be -4. So 1/3 times x is 12. So we need to go the other direction. So this must have started 3 times bigger. That must be the first entry, because 36 times 1/3 would be 12. 12 minus 16 would be -4. Woo! Seems tricky, doesn't it? All right, try the second box right here. What number is going to go in there? We're subtracting a 4. Subtracting a 4 and ending up with -8. So what number did we multiply by 1/3 and then subtract 4 to get -8? You might want pencil and paper to work on some of this. If you can do it in your head, fabulous. I'll see who can come up with that answer. We take a number and we multiply it by 1/3. And then whatever that ends up, we subtract 4. And the answer is -8. So can you work backwards? Mary's saying maybe -12. Oh, Caden's changed his answer. He's not sure, maybe. So let's do this. Let me write this down first. So 1/3 x being multiplied. And I'm just going to do the top row right now. So when we subtract minus, what do we end up with? -4 and -8 and 3. All right. So if we're trying to figure out the second number, that's going to be x. X equals. And we're trying to figure out this second number. The first number we said, all right, so this was 36. So all we know about this second number is there's going to equal -8. And we have some number that we're subtracting -4 from. Subtracting 4 from some number that we took times 1/3. We can just call this number x if we want. 1/3 x minus 4. So you can just write that out. 1/3 x minus 4, and then solve this. Add 4. So 1/3 times x equals -4. How do you get rid of a fraction? You multiply by what's on bottom. So if we multiply both sides by 3, 3 times 1/3 is just 1. So 1x. 3 times -4 is -12. So this is -12. Caden, you were absolutely right. You and Mary had it there. Lee was with it also. All right. And then the last one was subtracting the 2. I think I have that one written down as well. So if you're not sure, all I know is 1/3 x minus 2 equals 3. We can do the same thing over and over again. Add 2. So 1/3 x equals 5. Multiply both sides by 3. This equals just 1x, and 3 times 5 is 15. So we started with 15. We multiply it by 1/3. That means it's 5. We divide by 3. And 5 minus 2 equals 3. All right, so we said this one is 15. So if we have -8 equals -2, We add 8 to both sides. That gives us 6. So that must have been an 18 because we take 6 times 3. We subtract 1 and we get 12. So if we add 1, that's 13 times 3 must be 39. We subtract 6 to get 10. So if we add the 6, it's 16 and multiply it by 3 is 48. 1/3 x minus 9 equals minus 9. If we add 9 to both sides, 1/3 x equals 0, so x has to be 0. 1/3 x minus 2 equals 3, so add the 2. That gives us 5. And 1/3 times 15 would give us 5 because we multiply it by 3. And then minus 1 equals 1. So if we add 1 to both sides, it equals 2 times 3 is 6. Let's see how that works out. Not quite. Oh, what number did I mess up? So let's try again. One of those I messed up. I guess I'm going to have to write the rest of them on the paper. I wonder if I left off a negative somewhere. So let's see. This is 1/3 x minus 8 equals minus 2. Add 8. 1/3 x equals 6. So x equals 18. And we get positive, so 18. 1/3 x minus 1 equals 12. Add 1. 1/3 x equals 13. Minus 3 x equals 39. 1/3 x minus 6 equals 10. Add 6. 1/3 x equals 16. 16 times 3, 48. Wait, let's see, that's the same thing again. I see first one, 0 down there. 1/3 x minus 16 equals -4. Add 16. 1/3 x equals 12. See, x equals 36. So the shape. Here's the number. 9 equals 9. 1/3 x minus 9 equals 9. And 9. 1/3 x equals 0. By 3 x equals 0. That should be right. 1/3 x minus, this may be where I messed up, minus -2 equals 3. So this would be the same as plus 2. I bet that's where I messed it up. Because minus a negative. So subtract 2, 1/3 x equals 1. So x equals 3. I think that's the one I messed up. 1/3 x minus 1. Equals 1. Add 1. 1/3 x equals 2. X equals 6. So oh, see, I put 15. I'll bet that's it. The negative. What's the negative? Subtracting a negative. Let's try again. There we go. We're stuck with it. Come back and fix the -1. Next question. So, all right. So it's the same type of stuff. So the last assignment here, a little trickier because it combines some scalar. All right, and that's it for week 26. It combines the scalar and the subtraction together, or the addition. So 4 assignments, 2 with just addition and subtraction, and then 2 with scalar multiplication added in. So, whew. And then next week, all we have is the final lesson, and then just the quiz. The quiz is the only assignment next week. We do have lessons next week, but we're just having a quiz to finish it out. Then we'll be done with matrices. So one more week after this of matrices, and then we will move on to rational equations. So, all right, and I will go back and look to make sure everyone's assigned because apparently we missed some people. Addison doesn't have that in Khan Academy. So I can go back and fix that and make sure it's got everybody. So, all right, any questions? Everyone good? This is a B day Friday. So we only have class on Wednesday this week. So if your grade's below 70, get it up before Wednesday. You'll be excused from class. Otherwise, I'll see you Wednesday. Or if you have questions and this is confusing you to no end and you'd like to get help, come to class Wednesday. We'll work on it together. So have a great week. We'll see you next time.